to another episode. Today we're going to be doing the XML Serializer. The XML Serializer. Yeah, we're going to call it XML Serializer because this is what this is. Monster XML Serializer. The reason I'm giving such a large name is because you have multiple of these. You go, what do you mean? Well, this will only serialize it for monsters. So if you have weapons, you'd have a different one, and so on. So these are to be used across all. So this is where there's a lot of them. So you gotta make sure you have a using system.xml, using system.collections.generic, using system.xml.serialization, using system.io. A bunch of them. We don't want any of these. Next, make sure it doesn't inherit of mono behavior. Okay. Go to our monster array, we could call it our collection of monsters. And then we have an XML array of, so they're called monsters. So what this basically means is a group of them are called monsters, and a array item, and individually they're just called a monster. Simple. Public list of monster equals monsters equals to a new list of monsters. So what this is basically, these are all the monsters in our game. So when we start up, we'll load all these monsters from the XML file, and we'll save it to the XML file and stuff. But because this is modern developed, this isn't just used once. This is multiple times for multiple different scripts. So we don't say to the XML Serializer, hey, go save in the script, and then that's consistent across the entire game. No, we'd only do it once, and then we would load it, and then whenever anything else in the game ever needs that data, it would load it itself. So we're constantly reloading and loading, so we're not having a single copy of it, but we could have a single copy of it. But XML loading is quite lightweight and very little problems, so don't worry about just using it basically everywhere. I wouldn't really overuse it, like every time you're shooting a target, maybe don't go check your XML file, but you know, whenever you spawn a character, you can go, okay, check the XML file, this is his data, put it in there, and stuff like that. So it means if you change variables over time, it means things keep consistent. Anyway, we're gonna have a public void, could save, and we're gonna give it a path. And I'm going to talk about path in a second. Okay, because new monster XML serializer, type of monster XML serializer. And also, by naming it such a big name, it means you don't get confused between this and the actual XML serializer, which is basically, the only difference is one of them is in caps and one isn't. So I'll show you the example here. See how this is in caps and this isn't. This is the actual XML serializer, that isn't. So it's just way too confusing. So we're going to be using a var stream, new file stream of path. Now what we're going to do is we're going to say we're going to open or we're going to create. So if there's a file there, we'll open it, else we'll create it. And this is quite useful. Some reason it doesn't like it. Serialize. I didn't feel I did anything wrong. Oh, this is right. This is what. No. No, so this is right. This is wrong. There we go. This is why it was so confusing in my whole one, because there's two different versions. So this is the one we want. So we want to have a new XML serializer of type of this. And then we're going to serialize it, and then that's it. Okay. We're going to have a public static XML, monster XML serializer. I'm going to call it load. So any class can then load using this thing. It's very easy. There's this supply path to load from, and then we'll return this class, and from there they can access this class and access the monster class. You could have an overarching one, and it could load from multiple paths, and maybe you don't even want it to load from a path because the path's always going to be the same. You could do that easily. Don't worry, you can easily do that. And there's no problem with that. And then what you can do is from there you can just kind of load them all in, and all classes can use that, and you can even make it static, right, or something like that. There's many things you can do if you want to keep it consistent, but this is a very light look at it into the thing. It's a type of monster XML serializer. So the using command is a bit confusing if you've never done any C++, most likely. Maybe it's not to you, which would be great, but it could still be really confusing. Deserialize stream as XML, as monster XML serializer. Okay, so it's basically saying using a file stream. So we go to this path and we open up a file, and using opening up that file, we're gonna then return this class. So we then going to basically return the XML as a class. And it seems a bit confusing. These are going to be commands that you're going to constantly be using. Open or create is pretty useful, since if we open it then we serialize, obviously we're going to override. But most of the time I actually just delete the file before I save. So actually it's probably better just to create, since there can be problems. Actually I can Google this for Unity. Actually, why don't we do this? We can go here, scripting help. I mean, well, who cares? Go scripting API and go file mode. It's a binary file. States. I'm thinking of file mode dot open create. File mode open create. Where are we looking? Here we go. Okay, so append. It will be overwritten. Oh, I see. Okay, so we're gonna, in this example, we're actually just gonna create, and that does mean that we don't actually need to delete it because it'll override the file. So it does actually solve a bit of our problems later down the line, I found. But I mean, sometimes you do want to open it, right? But okay, but it'll be fine. Guys, let's continue. Okay, we don't want that anymore, we just want this. There we go. So now we're gonna, that's it, that's that script. Now we got more scripts. Have fun. There's only 2 more scripts, so we're doing pretty well. We've got data application, and we've got another one. We can use the data application first since we need it for saving, but I don't know how our time's looking. So our time's looking really good. Okay, so we'll do data application. Gonna put this under utility scripts because this is it's not really a utility script, but oh well. So this is just going to be display data. It's actually more than display data. It's basically data, individual data application. I'm just going to put data application. So like each one of these things will have a data application attached, and then that's how it works. So there's a few ways you can do things. You could do something which is what I'm going to be doing, which is a public enum called type of data. I mean, it's just kind of how I'm just going to do it. So you select your type of data, and that's how it's going to run things. I mean, you could do things like check the name, you can do many other things. This is a bit more static, but it's not too bad. It's actually okay. Type of data, and we're going to call it type. We're going to have a text. It's going to use Unity engine.ui. We're also going to be using system, and we're also going to be using system.io. So we're going to be having text. We're going to call this our output. We're also going to have an input field. Because it's input. I am someone who groups my things together, which is why that looks like this. Except for these, but I like separate them. Just makes sometimes things a bit easier to read. We're going to load our changes, and this is quite easy. When we're loading changes, we actually require a monster to load. And we're going to go as our index. Because originally I did actually have just like an integer index, but I think monster index actually, one's index obviously works a bit better. But so what happens is that, because this is a reference, because C# is full, basically, in C++, when I send you a file, you can edit that, and that doesn't always mean you actually edit my copy, because you will actually get a local copy, I believe. But you can use something called a reference, in which if it's this little and sign, and you can say, hey, I want a monster, the syntax is that, and obviously that doesn't exist in C#, but in C++ that means whatever changes you make to your local copy will also edit the the person who gave it to you. But in C#, it's automatically a reference. So it means any changes I can make to this will also change the original one. This is what we want here. It's not always what you want, but it's what we want here. Sometimes you can make it constant. Yeah, no, it doesn't want constant. I'm sure there's a way you can make it so that the changes you make won't affect the original one. I can't remember how you do it though. Regardless, type of data.hp, break case type of data.name, break case type of data.scary, break really type break and xp. And break. There we go. We're going to separate these. Actually, I don't mind doing them here. That looks fine. I don't know, I'm kind of finicky with these things, how they look. Oh no, I can't do that, that looks awful. Yes, okay. So we're going to change our output. .text is going to be out equal to hp plus index dot monster hp dot toString. Yay, simple. We actually don't need to do this toString, because we already have a string here. If you already have a string, you don't actually need to do this toString. Then this is where we do more stuff. If the index.monster.hp does not equal 0, then the input.text is equal to index.monster.hp. We do have to convert that one to string. Actually, I don't mean to do that. For some reason it did. Else, because we don't need it, so there's no equals. So why are we resending text? This means that, well, if the monster HP is nothing, or there's no type, then it will actually give you this little window here, instead of just saying, otherwise it would say something like here, monster HP, it would say like, I mean, no, not that one there, otherwise it will say, oh, like we'll move that, really. shows away. There. It'll be like, otherwise it'll be like just like 0, and that makes no sense. But you'd rather say enter your HP, because obviously 0 means there's no HP, and who cares even if that 0 is the HP, because if it is, then well, it doesn't matter. It would just say 0. It would just say enter your HP. And make him view. I don't know. I probably made that sound a lot more confusing than it actually is. And it's gonna be dot name. Yep. The monster name does not equal nothing, then dot monster name. Guess what? It's already a string. Yay! And then I'll also take seekers out. XP. I'm just kind of going up the list. Dot XP. .xp. Make sure you miss none of them, otherwise you will find a weird bug that may be annoying to fix. Actually, type's quite different, so we're just gonna completely remove that. And then scary is scary, right? Dot is scariness. There we go. If I'm just going to do that and just say input text equals index.monster scariness. Now, there's a reason why, is because otherwise if you said false it just wouldn't show, and you're like, that's weird. And that's why I think it'd be good, because then if, at least if you had like a third variable like null, it would still equal false, but like at least would say you need to enter a value. I don't know, for some reason it'd be nice. I don't know. Okay, type's quite different, so we'll do that now. Output.text. The first bit's normal. Best of my memory. Monster type. There we go. .toString. Easy. Well, technically I don't need a toString because it's a. There, that's pretty easy. This is where we check it. If index.monster type. It's not really different actually, if you think about it, but still. None. If it's equal to none, then guess what? You just do input.text. I mean, if it does not equal null, then you can just do index.monster type to string. Yay. Else. That should work. I'll have a look at that in a second. Should work. There's no reason it's not. There's a bunch of these weird ones. For oh, I said for. It should be if. There we go. I was like, for this, no, if. That, oh no, it's actually multi-type too. As we want to try, this will mean that the game won't crash if we enter type that doesn't exist. This is where it's different. Yeah, this is what I remember. Enum dot, because we had the system up here, we can just go enum dot pass type of monster dot types and input dot text. Shoot. It's actually quite different than what actually I did. That's why. If input the text, I know I must have been looking at the wrong one because I was like, this doesn't look right. equals monster type dot none. Like that. And what does this? So there's a few things here. True means we ignore case. So as you see, pass is a few things. There's the enum type, which is monster types. The value, which is input.text. And the ignore case means that we're ignoring the case, which basically means that capitals or non-capitals we don't care, which is big. Then we'll use a catch. We're going to catch an argument exception. Make sure you catch an argument exception. If that's not there, make sure you have system and system.io. I think one of them has that. Can't remember which one. And then we're going to do a debug.log. Say input.text plus isn't in the enum list. And what this means is, instead of crashing the program, it will just do a simple debug, and we could save that to a file or whatever. So it means that it's still gonna be great, fine-ish. And if there's an error, then what we're also going to say is we're just going to say index.monsterType .monsterType.none. So it means if there's an error, then we go, hey, well, your monster type's now equal to none as default. It should be anyway, but it's just a double check. Double checks are big in the coding industry, because the more times you double check variables and don't assume, the less errors you'll have. For some reason, I clicked on that. There we go. Beautiful. I think we've got a variable it's not liking. Is it going to show up for me? No, not yet. Okay, then we got saving. So our saving script, this saves, this loads, this does everything. And you go, oh yeah, the reason it's catching but never used, let's go press E dot, I don't know. There's a quick way you can make it so that error goes away. You just turn to a string. It's very, very low maintenance, and it will make it go away. Even though the string is instantly trashed and no one cares about it, the computer goes, hey, it's still being used. It's stupid that happens sometimes, because sometimes you want to catch the error, but you don't want it to do anything with it. You just go, well, yes, it's an error. You know what error is about, so there's no point saying it. And anyway, so saving, this is going to be obviously going off monodevelop. We're going to have an awake core, and we're going to have an update, but we're not going to be using them for them well. So data applications, we're going to have a array of them. We're going to cause our data to load from, load save from. That's too long. I'm just gonna code data. So, all the names, all that stuff. We gotta use a few more things, such as using Unity, engine.ui, and using system.io. That should be it, but there may be one or two others. This is the last script, by the way, so, sorry, just using text. Index, visual display index. It's a bit long, but who cares, we're only using it once. Integer is current index, 0, integer amount, which is equal to 0. So how many entries do we have, and our current index. Because remember that our XML serialization isn't static, so we don't want to be getting every second XML serialization. Now that's overboard. If we were doing that every second, that would be taxing. So, I mean, every frame, not every second. Oof. Kind of like every second's taxing, so every frame's going to be insane, right? That's 60 times a second, that's insane. Regardless, we're just going to do a very simple visual display index.text is equal to index, and do just do this. And there's a few things you may be wondering why. You may be wondering why this is in brackets. If this isn't, it will just do the current index and then add a 1 in the end. So 0 becomes 0, 1 instead of 1. So, So if our current index is 0, then it will become 0, 1 out of 1, which is not what we want. We want 1 out of 1. Alright, because 0 or 1 seems like there's one more when there really isn't. It's just that obviously our current index is always going to be 1 behind, so that way it makes it looks good. Okay, got a few things. The problem is all our functions use each other, except for load monster. So we're going to do load monster first, because save monster actually uses load monster. Because after it saves, it loads it. Just to double check things. So load which monster index. XML equals new. The reason I'm saying it's equal to a new one is because if the file exists, and we're going to do a, this is where it gets a little confusing, so I'm just going to write it out, then explain it. Lowercase, make sure you write this the exact same, because if you write this wrong, it's going to stuff up everything and you won't even realize. Oh, sorry. Dot load, because remember that was a static function. You may go, oh, you're gonna write this a lot of times, aren't you, throughout the entire thing? Yes, you are. So you can do a few things. You're gonna write this maybe like 10 times. So if you really don't trust yourself, I mean, it's not that hard to use writing monsters.xml. But if you really don't trust yourself, just make it public. Just make like a static string and call it monsters.xml. Or if you really make it constant, whatever you want, right? And just make it application to data path past monsters.xml. Very simple. Okay, so if the file exists, so that means that we've got, so this is not going to be useful in everything, but it's going to be useful in this example. So in this example, if you load the first time you load into the game, there won't be a file for it, right? Because there's no monsters yet. So that means if there isn't a file, then trying to load for that file will receive an error. So what we do is we're going to, oh, there's one. So you save monster, and you go, oh, what, save monster? Yeah, we haven't defined that yet. Basically, save monster is special in the way that it actually will just create a new, what's called a new monster if there isn't one. So, for example, it's going, hey, we don't have a save file, right? So save monster will then create a save file for it to then load. So what it's doing is saying, hey, create a save file for me to load, because it still needs to load something, right? So it just goes basically, hey, you don't have a file, go create a file for me, and then I'll load it. That's all what save monster does. And save monster doesn't take anything, yes. And then we're gonna have a few helper functions in a moment. So just to enter the stuff in, obviously this won't work until we've got all the scripts, but still. Let's just keep running this, then I'll explain it. We can probably base that. So, if the index is greater than the monster's count, so you're basically saying this will only work. Do you know how I could keep pressing right and it'll keep like adding one on the end? Well, that's a function that's quite useful to have. You want that in a lot of things, and this is just for that, right? Just for that example, it will just do it. So if there's one too many index, it'll go 8. Okay, I'll create a monster for you. There'll be an error. It's say you're trying to access index 84. It will just create index 3 and then try to access index 84, which doesn't exist. So still there's an error there, but that just is weird, and I don't know why you'd be trying to do that. I don't know. Like, makes, maybe, I don't understand why that would make sense in like a normal situation, so, oh well. Data of I.load changes of XML.monsters of index. So we're saying, hey, load these changes of this monster. So it will load all the, it basically just loads all the variables. Because load changes is pretty cool. I think it's actually, wait, I thought there was save changes too. Oh, it's just the save changes. I totally missed it. Let me just quickly do save changes. I was like, what? I was like, this is not right. But I'm glad I found it now. This is gonna be annoying. Yeah, I'm just gonna have to do this. It's HP, then what we're gonna do is we're gonna do integer.try_parse, and then we're gonna put input.text. Oh, this is where I got totally confused. Oh, I'm sorry, guys. Oh, wow. Yeah. This is, I totally mucked up, sorry. I feel really bad now. Because there's so many of these freaking cases. They look so similar. I looked at them and got, oh, wait, what? I'm tired as today. Probably shouldn't have recorded. So this thing here, this doesn't go here. Yeah, no, knowing right. This goes down the bottom here. Rather, something completely different goes here. Output.text is equal to XP. Oh, not XP. Damn it. See, I'm still working out because my version on my right, which I'm copying off to make sure I don't make any mistakes, stupidly enough, has these in a slightly different position that just completely thrown me off for some reason. Monster type does not equal monster type dot none. Input.text is equal to index.monsterType dot toString. Else input.text equals that's good. Okay, let's keep going. We're gonna put a few more cases here. Going to do a boolean .try_parse. We're gonna put index.text and out is index dot scary. Then we try type, we've just done that, and then the last one is this, which is just gonna be a float .try_parse. I don't know, I didn't realize that it's showing up when I was actually doing it originally. I should have been like, hey, look, I'm saving here, but no. Apparently I didn't. Okay, this is gonna go for one more episode. XML.monsters.count. Let's make a few helper functions. Public void load monster right. Load monster of ++ current index and save monster. I don't know why I'm saving, but apparently I am. I know there's a reason I'm saving. I think there's a reason. Because saving loads it anyway, right? So if I just save it, isn't that what I want? To just save? No, there's a reason why I'm saving, yeah. I think. Oh, I would just try it without saving, and we're saving to see if it works. And someone would say, oh, you don't need this -1 if you make this 0. Yes, but then it makes it unreadable for people who are coming by, because they don't understand that we're minusing 1, obviously, because we're moving to the left, and -1 obviously checks that if we're at 0 point, then we don't want to move, right? So sure, we can make it current index is greater than 0, and it could still maybe make sense to some people, but this way it definitely 100% makes sense. And this minus, by the way, sometimes you'll see it like this, sometimes you'll see it like this. This essentially, if I did it like this, it minuses 1 first, and then it minus or equals to 1, so it makes, well, let's say current index is 5, we'll make it 4, and then it will give the function 4. But if it's this way, it will give the function 5, and then minus minus, so it becomes 4. So it's when it gives it to the function, basically. When we awake, by the way, we're going to load monster 0, just so I don't forget that. Save monster is pretty short to monster serializer. XML equals new. If file exists, let's go and post this. If the file exists, then XML.monsters equals XML Serializer dot load of if current index is greater than xml.monsters.count minus 1. So as you know, the last index, if our current index is greater than the last index, then okay, there we go. Then xml.monsters.add new monster, yay. Else this should be pushed up one. For int I is equal to 0, because obviously we don't want to do this if we're doing other stuff. I++ data of I dot save changes dot monsters of the current index. Well, technically we don't need this either, but still, it's probably nice having it. Oh well. If file, the file exists, then file.delete. Gee, no, we don't need delete here. Sorry about the noise in the background. Just save. Okay. Then we're going to load monster of the current index. That should work. Oh, we will add a new monster function. We save monster. Ta-da! Oh yeah, you always need to save monster afterwards. There must be a reason. Oh yeah, I understand why we save monster now. Because if we don't save the monster, then it means that if the game quits, then obviously, but since we're saving it here, yeah, no, we need to save it because it means that if you quit it, there's still the extra monster slot there, even though it's fully empty. For some reason, I wanted to have that. There's still one more function, and then there's a few other things that I have to do, and that will be all done next episode, since this is up to 40 minutes. So, see you guys next time.